Alright guys, let's go ahead and get started. So the last few classes we've been graphing sine and cosine. So after last class I had a student come up and said, I feel bad, why aren't we graphing the other ones? And I said, that's a good idea, let's do it. So we're going to graph tangent, cosecant, secant, and cotangent. Alright, now, here's the good news. I know that sounds intimidating, but all you need to know in order to graph those is sine and cosine and what you already know about the unit circle. The other thing is that when we graph these, we're only going to do like basic transformations, nothing too crazy. But I like it because it's fun to teach you guys something new that you haven't seen before. And I know for sure you've never seen this before, right? Has anyone seen the graphs of tangent? Or Charlie, was that a yes?
I was making a joke.
Oh, okay. You're like, yeah, that's what I do on my free time. I graph functions, trig functions. Okay. So let's just start with our basics, okay? Let's start with how do you graph sine, how do you graph cosine. We did the wiki stick activity that hopefully this is ingrained in your brain. But let's go to Charlie. Help me out with sine. How would I graph the parent function for sine?
You'll start at 0 and the period of it is 2 pi. And so the middle point would be pi. And then you'll go up at pi over 2, you'll go up 1. And that's 3 pi over 2, you'll go down.
Awesome, and then we'll just continue with that. I like how Charlie did this because sometimes people will just automatically for every space go up, down, and that's not the right spacing. So I like how she did start and a stop, and then so now we can graph this. There we go. There is sine. Awesome. Okay, so Adam, help me with cosine. How would I graph that parent function? Well, it's kind of the same thing. Let's go back to our wiki stick, though. What was the difference between sine and cosine? When we're measuring sine, what were we measuring? Do you remember with those wiki sticks? How were you holding those? The height, we're saying, how tall is it? And that's why at 0, it was 0, and then at 90 degrees or pi halves, it's 1. But what did we change for cosine? It was the length. Good. So now what is the length at 0? The length is actually the whole thing, which is 1. So the height here, if I look at the point right here on the unit circle, this is a point 1, 0. So the length, which is x, is 1. The height is 0. So cosine is going to look a whole lot like sine, except it starts at its maximum point, which for the parent function is 1. Has the same period, so we're going to go all the way to 2 pi. But now at pi, it's going to be at its minimum point, which is negative 1. There you go. There's cosine. Now, you guys have done a lot of work with this. You need to have those memorized. What we're going to do is use these to help us get our 4 other parent functions, okay? So let's start with cosecant. What is cosecant the reciprocal of? Sine. Now, do me a favor, I need you to get out your unit circle as well, okay? If you don't have that out already. So let's think of this. Cosecant is the reciprocal of sine, 1 over sine. Now, when we were going around the unit circle, okay, how were we figuring out sine? What were we looking at? That is such a bad circle. But all right. But when I was looking at my values, we said the x was cosine and the y was sine. So what we're going to do is we're going to go and take all of these y values, and what are we going to do to them? Do the reciprocal, flip them over, right? Now some of those it might not look very pretty, but which y values will be okay when we flip them over? take a second and look through all your y values and think which one of those is okay when I flip it over. Someone shout it out when you see one that's okay. 1/2? Alright, we like 1/2 because what does that turn into? 2. Okay, so where was sine 1/2? Alright, hold on, let's back up. Let's try this a different way. Let's just graph sine, okay? Take a second, I want you to graph sine on here. So this is just plain old sine, right? Now, instead of you looking around, let me just tell you the ones to look at. Let's look at 0. What is the sign at 0? So the x is 1, the y is 0. Okay, so this is what the sign at 0 is, right? What is the reciprocal of 0? Do not say 0. Yes, because what happens when you divide by 0? We talked about this before. Remember that USS Yorktown? And it shut it down, it's undefined. Okay, so what we've graphed before, what do we put when it's undefined? Think of your rational functions. Remember how when with the ninja star? What do we... A vertical asymptote. Good job. So at 0, the reciprocal of 0 is 1 over 0, which is undefined. So I'm going to put a vertical asymptote at 0. Okay, so now let's go to 90 degrees. What is sine at 90 degrees? It was 1. Guys, what's the reciprocal of 1? It's 1. So 1 over 1 is still 1. So at 90 degrees, or pi halves, it's going to be 1. Do you see how it's sharing that same spot with sine? Nice. Okay, let's go to 180 degrees. This is a point -1, 0. Uh-oh, once again we see that sine is 0. So what will the cosecant be? Undefined, which means what are we going to put at pi, or 180? Vertical asymptote, right? Because when it's undefined, we don't want anyone to use that point, so we put a vertical asymptote. Okay, now go with me to 270, or 3 pi halves. This is 0, -1. Guys, what is the reciprocal of -1? It's 1 over -1, which is what? -1. So I'm going to put a dot at -1, and do you see how once again it's matching up with our sine graph? Okay, now what's going to happen once we get back to 360? It's going to be a vertical asymptote. And we're just going to follow this pattern again. And then it will be 1, and then a vertical asymptote. And then it will be -1, and then it will be a vertical asymptote. Okay, now the question is, what's going on in each of these here? Okay? So that's where we could start to look at other points. So for example, what was the height? You guys said that at some point in here, it was at 1/2, right? What angle was it at 1/2? Say it louder. At 30 degrees, the sine was 1/2. So then, what's the reciprocal of 1/2? And then also, it wasn't only at 30 degrees, it was also at 150 degrees, right? You see 1/2 there? So what I'm going to do is I'm going to put a point here at 2, where 30 degrees, or that's going to be pi 6, okay? So I'm going to split this into thirds. And over here, I'm going to put one right there. Guess what shape we're going to make here, guys? It does, but it's actually going to be a U. It's not a parabola, but it's a U shape. All right, well then look at your -1s here. What are easy values to take the reciprocal of that you see on the bottom half? Man, you guys gotta wake up. You're killing me here. What ones did we take the reciprocal of? Just barely was 1/2, right? What do you see over here? Negative 1/2. What's the reciprocal of negative 1/2? -2, right? So what this means is that I'm going to have this U shape, but it's facing down. And what's going to happen as we keep going? It'll keep going like this. Okay, so guys, that green shape right there, it's cosecant. All we did is we graphed sine, and at the peaks we put a U, and at the low points we put a flipped U. That's it. Okay, now do me a favor, I want you to get out your Chromebooks. Let's go to Desmos and check it. And we're going to check all of them that way, and then we'll also be able to check our transformations, okay? Yes, LaSharon. You have a note? What time is it for right now? Okay. Yeah, just hurry back, please. Now, I'm gonna keep going here. We're gonna end up checking all of these while your Chromebooks are warming up. Okay. If this is what cosecant, which is a reciprocal of sine, looks like, let's see what secant, which is a reciprocal of what? Cosine. Let's see what that looks like, okay? We're going to do the same thing, but it'll go faster now, because you guys, first, you're awake now, right? And also, we've seen it. You're not awake? Wake up, Micah. Okay. Guys, graph cosine. You're multitasking here. Signing in and getting Desmos pulled up, but then also you're graphing cosine. Hiram, tell me how to graph cosine while we're all doing this together.
You start at 1, and then you go down by half, and then you go down to -1 and pi.
And then we just keep going. All right, great. Thanks, Hiram. Now this one's going to be a little bit different, but I'm going to show you how to do it a little bit easier. So these are the values of cosine. So we actually don't need to look at our unit circle, we just look at the graph. And what did we say we can't divide by? 0. So what are we going to put there? Anywhere that cosine is 0, what are we going to put? We're going to throw up a vertical asymptote and say, no one use this point. No one use that point. Now, what's going to go in between the vertical asymptotes? It's going to be a U. How do you know if the U is going up or down? Peak or the valley, right? If it's a peak, it's up. If it's a valley, it's down. So I'm going to share this point because the reciprocal of 1 is 1. It's going to go like that. So this purple point right here, this is secant. All right, so what I want you guys to do is let's go ahead and let's pull up Desmos. I think my internet still works when I'm disconnected, but let's try it. Sweet. Okay, so you got Desmos pulled up? Let's start by graphing sine. Oh, that's not what I want. I guess I got to push it. I'm just going to do sine of x, okay? There is sine. Doesn't that look pretty? Then, for the next one, I just want you to put in 1 over sine of x. Okay? So I'm going to do 1 divided by sine of x. And doesn't that look like what we came up with? Notice, at all of the peaks we put a U, and all of the valleys we put a flipped U. And anywhere that sine has an x-intercept, there's a vertical asymptote. It doesn't show up on the graph, but you can see it because that's what it's approaching. Isn't that pretty? Now, you could erase this, but I think it looks cool. So actually, I'm just going to pull up a different one. And what are we going to graph here, guys? Cosine. So I'm going to put in cosine of x. What just happened? And there's cosine. It starts at 1 instead of starting at 0. And then I'm going to do 1 over cosine of x. And there we go. We could see the same idea. Because it should make sense. Sine and cosine are basically the same graph. One just starts at 0 and one starts at 1. So their reciprocals should look the same. It's just shifted over, right? So there we go. There's what they look like. So when I say, what does the graph of sine look like? You make a little loop-de-loop thing, whatever. What does cosecant look like? Then you're going to have use and flip use. It's going to look like that. Same with secant. It's just you have to know where it starts. So here's my advice. If you need to graph secant or cosecant, I always just graph sine. And then, so for cosecant, I graph sine and put the u's at the peaks and valleys. Or I'll graph, for secant, I'll do cosine. Does that make sense? Not too bad, right? You already learned 2. You guys are good. So let's go back now. We've got secant, we've got cotangent. Secant and cosecant, now we've got to get tangent and cotangent out of the way. Now, when we first were reviewing tangent, how did we think of it? We went and learned this on What did that mean? What does TOA tell you? Tangent is what? Opposite over adjacent. But then we got onto the unit circle, and we thought of it a little bit different. We thought of it using letters. We said, all right, well, the opposite side is the y value, and the adjacent side is the x value. But then we learned that on the unit circle, the y value is sine. And what was the x value? Okay, so here's what I want you to do, just real quick. So what we're going to do is we're going to take our values of sine and divide them by cosine and see what happens. To help you do this, I want you to take 20 seconds and graph sine there, 20 seconds graph cosine there. Actually, graph cosine in the middle. I made it bigger, but it'll just be more easier for us to think these values divided by these values, and then this one will give us tangent over here, okay? So, graph sine and cosine, and then we'll divide those and see how it gives us tangent. All right. Does your sine and cosine match my sine and cosine? Okay, now to get tangent, how are we going to find tangent? We're going to do values of sine divided by values of cosine. So what we're going to do is we're going to take this value, sine at 0, divide it by cosine at 0, and that will give us tangent at 0. Okay? Let's do that. So at 0, what do we have for sine? 0 divided by 1 is 0. We're okay with that because it's divided by 1. So tangent at 0 is 0 because 0 divided by 1. You with me? Now let's go to pi halves. I'm going to do 1 divided by 0. Uh-oh. What happens when you divide by 0? Good job. So it's undefined, so I put an asymptote there. So then I'm going to go to pi. 0 divided by, 0 divided by -1. still 0. Can you be negative 0? It's just 0, right? So it's going to be 0. And then I'm going to go to 3 pi halves. Negative 1 divided by 0 is what? Undefined. No bueno. So I'm going to put another vertical asymptote there. Are you seeing a pattern? What do you think we're going to have at 2 pi? Let's check. 0 divided by 1. Yep, that's going to be 0. And then what about at 5 pi halves? We're going to get undefined. And it's just going to follow this pattern. Now, we could go more meticulous here, and we could figure out like the exact values between those, but it gets a little crazy. Let's just look at something instead. Let's look at, is it going to be positive or negative? Okay? So, here between 0 and pi halves, I'm positive. What am I over here? Is it positive or negative? Don't look at where it's going. Is it above the axis or below? So we have a positive over a positive, which is what? Positive. That means over on between 0 and pi halves, it's going to be positive, which means it's going to go up like this. Now, what about between pi halves and pi? I have a positive, and here I have a negative. What's a positive divided by a negative? So here it's going to be going down like that. But then, from pi to 3 halves, it's a negative divided by a negative, which is a positive. And what you're seeing here, guys, what is this? We're making our kind of S-curves. Granted, they're a little bit different than what we've seen before, because they're bounded, but it's still making kind of an S-curve going up like that. So I think of tangent, I think of snakes slithering up. Tangent, they're slithering up. Can you see all those snakes? If you need help visualizing it, then you can draw this a little more snake-like, and then draw a little tongue. Now do you see it? Okay, there you go. So the snake slithering up. Now, how are you going to remember this, okay? You can remember it snake slithering up, but sometimes people get confused between the x-intercept and the vertical asymptotes. So I say just draw the graphs of sine and cosine and divide sine by cosine, and just that way you for sure get it right. Okay? Now, we got one more. What's our last one? How are we going to think of cotangent? Instead of sine over cosine, it's cosine over sine. So now I want you to do cosine here and sine here. And then I'm going to give you a chance to just try to do this on your own. I want you to figure out what happens when I take values of cosine and divide it by values of sine. So I'm going to give you a few minutes to come up with the parent functions and then try to come up with this on your own.